The statement of a well-known TV...
All right, guys. Hello. Grade 8s and grade 9s. So I just wanted to take some time. I thought I could see that some of you have been graciously answering the questions that you're seeing here, which is nice to see. So someone has asked a question here. Sorry, TK, if you're still here, you asked what happens if you're asked to prove that triangles are congruent in a rhombus but not given any measurements. So hopefully that rhombus that you have will have diagonals. Okay. Yes, okay, Rabbit, so it will be nice. You do 6.1 and you can help me out in the comment section. Maybe we can have people join in. You can request as a guest and we can hear your human voice, and you can take us through 6.1, how you did it, and what would be the way to go about answering 6.1. Let's focus on 6.1 a little bit, and then we will answer that question that has been asked by one of the viewers about how do you prove congruency in a rhombus where you have not been given anything else but the rhombus itself. So we'll look at that. We'll look at it just shortly. But can we just do 6.1? So for instance, I know that someone earlier on did go ahead and say x is equal to, I think it was Tatejo. Tatejo said x is equal to 180 minus, this is the comment, I'll pin it here. But Tatejo just needs to be careful that when she does this, she must make sure that that 180 minus 75 and that positive 55, that positive 55 needs to be negative 55 if you have written the numbers separately like that. Or if you want to retain the plus 55 at the end, you must say 180 minus, then you must write brackets, before 75 and then after 55. That ensures that your mathematical statement is correct. Then you write the reason after that, you see, which is very important. So I like what we see there. You write your reason after that. Your reason must also align, guys. If you are a grade 9 learner, you are going to grade 10 next year. I want you guys to become familiar with using acceptable reasons. Acceptable reasons. There's a document that the department gives, which is called the acceptable reason document. It has all the reasons that are listed for all the theorems, for straight lines, for parallel lines, for triangles. So that document, when you are able to align yourself with the reasons that are in that document, and you get used to it now whilst you're in grade 9 and in grade 8, it makes life easy when you're in grade 10, 11, and 12. Because markers or examiners in grade 12 are looking for learners who are able to use those reasons. Of course, your reason may not really be like the one that is written in the acceptable reason document, but it's better to start getting yourself used to that way of writing. In grade 8 and 9, they are not that strict, but in grade 10, 11, and 12, I can promise you this. It's important, So I think we can all agree then that for 6.1, right, we can see that 55 degrees, angle B3, angle B2, and angle B1, they all share a common vertex, which is B. They share a common vertex, which is B. Okay, a vertex is a point where lines meet. That's what a vertex is. So B is our vertex. So angle B3, which is 55 degrees, together with angle B2, which is 75 degrees, and angle B1, which is X, if you add those all together, they should give you 180 degrees, because these angles, 1, share a common vertex, 2, they are on a straight line. So for angles to add up to 180, there needs to be these two conditions met. The first condition is that they need to share a common vertex. So B is a common vertex. Then 2, they need to be lying on a straight line, completing the straight line. Okay, this is very important what I'm saying to you guys, because angles on a straight line is not angles on a straight line in any other way. Okay, so if you are someone who is here and you are watching this, I need you to walk away having clarity on what we mean by angles on a straight line. So just very quickly, let me do this then now. Nice. Okay. In Afrikaans we say yoga. That's good. That's good then, Juice. All right, because like I said, I'm not an Afrikaans speaker. Neither do I teach mathematics in Afrikaans, but I'm sure you will help our Afrikaans brothers and sisters that are in the life. So like I was saying, guys, these 1, 2, 3 angles, these 3 angles, we say they share a common vertex. So B is a common vertex. And then secondly, ABC is a straight line. So when you have these 2 conditions, they share a common vertex. 1, 2, they are adjacent. In other words, they are next to each other. And 3, they lie on a straight line and they complete that straight line. Okay, please guys, very important. So I'm saying ABC, right, is a straight line. So 1, these 3 angles, they all share a common vertex B. That's the first thing, first criteria that qualifies it as angles on a straight line. 2, they are adjacent. In other words, 55 degrees, 75 degrees, and X are all next to each other. This is very important. So 1, they must share a common vertex. 2, they must be next to each other. 1, 2, 3, they are next to each other. And 3, they are both lying on a straight line, sharing a common vertex. And what do they do as well? From here to there, from there to here, and then from here to there, completes the straight line. So they are adjacent next to each other, 2, and 3, they lie on a straight line and complete it. It's like your protractor. You see that instrument that you use, your protractor. The protractor starts at 0 and it ends at the end at 180. So that is why, guys, we can say the following: X plus 75 degrees plus 55 degrees is equal to 180 degrees. That's why we can say this, because 1, these angles 55, 75, and X, they share a common vertex B. 2, they are adjacent, they are next to each other. Adjacent means next to each other. 55, 75, and X are next to each other. 3, they lie on a straight line and complete it. From here to there, from there to there, and from here to there, completes the straight line. So then therefore we can say X plus 75 plus 55 is equal to 180 degrees. What's the reason? Angles on a STR for straight, short for straight, and then the line. And then we close the brackets. So what this does is that we write our statement. This is a statement. And then we must write a reason. So we write a statement followed by the reason, and that ensures that whoever is marking my work can see that I know what I'm talking about. I can see that there's a shared common vertex, which is angle B. 2, there are adjacent angles 1, 2, 3. 3, they lie on a straight line and they complete it. If you have these 3 things, guys, then you are 100% correct. You are saying things in the right way. GK, the other one that they do accept, okay, it's not in the acceptable reason document, but you can say adjacent angles on a straight line. You can say this as well. Okay. The other one, this one that you've just written down, I would discourage it. I would discourage it. Supplementary adjacent angles. I get your point, but like I said, there's a document, guys. The reason why, for instance, you will never see me use any other reason besides this one is because the nationally accepted reason according to the document that has been given is this one. So at angles on a STR line is an acceptable reason, okay, that is basically used. Sometimes I know people use this one as well, and it makes the point clear, obviously, that these angles must be sharing a common vertex adjacent to each other. So this reason obviously makes perfect sense. Angles on a straight line, sometimes the error that learners make is that they just think as long as it's angles on a straight line, then it's fine. But because here's the thing, I've seen learners do the following. For instance, they'll say, let's say you'll have an angle here, let's say this is 30 degrees, and then let's say you'll have an angle here, it's 120 degrees. You know, and learners think that if you take 30 and 120, you add them together, it should be 180 degrees. Why? Because these angles are on a straight line. And I'm saying, no, it can't be. Okay, yeah, it can't be. All right. So the point that I'm making here is that angles on a straight line, the angles need to share a common vertex. So we can see vertex B is shared for all these three angles. This is angle EBC, this is angle DBE, this is angle ABD. Common vertex, it needs to be there too. The angles must be next to each other. 55, 75, and X are all next to each other. And lastly, they need to lie on a straight line, and they need to complete that particular straight line. If they do, then we can qualify them as X plus 55 plus 75 is equal to 180 degrees. And then our reason, angles on a straight line. This is the acceptable reason that is in the document, angles on a straight line. Then we can solve the value of X. X is equal to, now very easily, we can take the 75 and the 55. Remember in grade 8, when you were doing expressions, on the left hand side, how many terms do we have on the left hand side of this equation? Remember, when you did algebra, expressions, terms are separated by a plus and a minus sign. So the terms that you have on the left hand side, there are three of them. There's X, there's 75, and there's 55. There are three terms. So what you can then do is you can take these two terms that you have X isolated on its own on the left, and you can transpose, meaning you can move 75 to the left, to the right, and 55 to the right. What happens is that when they move to the right, the 75 becomes negative 75. The 55 becomes negative 55. And then when you solve for those values, you can then obviously subtract 75 and 55 from 180, and you should then get the answer. Okay, so this is 180 minus 130, which is actually equal to 50 degrees. So that is the value of X. All right, straightforward. Okay, so please guys, let us get into the beautiful habit of being able to write our statement and then our correct, appropriate, acceptable reason, angles on a STR line. Okay, and then we solve and we get the value of X, which is 50 degrees. Okay, sounds simple enough, good enough? I hope you guys are good. Right, okay, now moving right along. moving right along. This was our next question. So 6.1 we are done. Let's look at this one, 6.2. In the figure below, CS is parallel to HN. CS is parallel to HN. That's good, TK, I'm glad. CS is parallel to HN. I'm sure you can see where CS is, you can see where HN is. Then they are saying angle EAW. Angle EAW is equal to 70 degrees. If you look at angle EAW is equal to 70 degrees, the statement is there, but if you look at the diagram, that 70 degrees is written, is inserted in the diagram, so we have it, which is great. Then we are told told AE is equal to AW. We can see the markings for EA being equal to AW, guys, we can see that. Then lastly, angle CAE is equal to X. We can see the marking there, we can see X is in the diagram. It is CAE. The angle CAE is X. Now they say give a reason why angle E2 would be equal to X as well. Right? So why, guys? Why would angle E2 be equal to X for 1 mark? What is the reason? Why is angle E2 also equal to X? Why? Now remember, guys, when you write your reason, please write your reason. Let it be complete and full. Do not give me a half-baked reason. Give me a fully baked, not half-cooked reason, please. Okay, so I can see people are saying alternate angles, alternate angles, alternate angles. And then I can see someone sticking out their tongue. Ivani. Hopefully God will hear our prayers. Ivani mitandazo yetu. TK has just warmed my heart today with the reason. Please take note of the reason that I've just pinned there. Okay, guys, you can see there TK's reason. Okay, it's full. That's a full reason. Why is E2 also equal to X? Remember, guys, we are told that angle CAE is X. Now we are being asked, why is angle E2 also equal to X? If you look at the pinned comment that I have pinned there, okay, yeah, we just need to be careful with the parallel lines there, TK. Yeah, because this is CS, this is HN. All right, so if you look at this, this is my Z or my N. Okay, remember for my fun, we have what we call corresponding angles. We have what we have as co-interior angles, and we have what we know as alternate angles. Okay, and every time, guys, we identify either on top we are equal, those are corresponding angles. Bottom of this line, bottom of the other line, those angles are equal, those are corresponding angles. So we say corresponding angles, and we always state the lines that are parallel. This line is parallel to that one if the relationship is corresponding. So our F shape, on top of this parallel line and on top of that parallel line, we say the angles are equal. Those are corresponding angles, and we always state the lines that are parallel the minute we say corresponding angles. As our reason, we say corresp angles, and then we state those lines that are parallel. So we are equal with corresponding angles. Top, top, you are equal. Bottom, bottom, we are equal. Top, top, we are equal. Bottom, bottom, we are equal on the same side of the line, which we call the transversal line. Very important. So those are corresponding angles. That's F. Then we have U, the U shape or the C. I call these the armpit angles. If you look at your armpits, they stink, right? Your stinky armpits. If you have your two arms, I call these arms. If you take your arms in front of you and you put them in a parallel horizontal state, then you have your armpits there, right? What do you do to your armpits when they stink? You add roll on. So we say that the sum or the addition of these two angles gives us 180 degrees. These are co-interior angles. So the co-interior angles, when the lines are parallel, yes, they do. Eh? So that's why I usually remind learners that you need to add roll on, or you need to add something that will make them smell good. So the sum, the addition of the two angles gives you 180 degrees. These are what? Co-interior angles. But whenever you say co-interior angles, you must not forget to state the lines that are parallel. You must state the lines that are parallel for your reason. Okay? Then the last one is our N shape. Sometimes referred to as Z when you put it this way, or sometimes the Z that looks like this. All of this speaks to alternate angles, guys. 1, 2, 3. The lines are parallel, these angles are equal. The lines are parallel, these angles are equal. The lines are parallel, these angles are equal. We call these what? Alternate angles. For short, we say ALT, angles. This is the symbol for angles. Then we must state the lines that are parallel whenever we use them. So it's very nice when you can remind yourself. So Z, N, or the funny looking Z, lines are parallel, angles are equal, but you must always state the lines that are parallel for your reason. So we're coming back here now. If you look at this, we are asked the question, why is angle E2 also equal to X? Remember, we were told that angle CAE, meaning this angle, is also X. Now we are being asked, why is angle E2 equal to X? So we can say angle E2 is equal to X. What is the reason? If we go back to our F, our U, and our N, this angle and that angle give us which relationship? Which relationship do we get? Is it an F relationship corresponding? Is it a U relationship, the sum is 180? Or is it an N or a Z relationship, which is alternate angles? Which one is it? Which relationship are we looking at? Because we are told that these lines are parallel. And obviously this here gives us a relationship. This X and this 2 give us a relationship. Yes, you are 100% correct, Lifa. Lifa, it is the Z effect, the Z relationship. Hello, babe. It is definitely the Z relationship. So when we write the reason why angle E2 is equal to x, we say, guys, alt angles. And then after that, we must indicate the lines that are parallel. CS is parallel to what? To HN. Is it important that you state the lines that are parallel? Yes, you must. Failing to state the lines that are parallel is not giving the full reason. If you don't state the lines that are parallel, then you are giving me a half-baked reason, which is not complete. Okay. Please, I beg you, don't ever forget to state the lines that are parallel. So in essence, what am I saying? I'm saying that whenever you use corresponding angles, please identify the lines that are parallel for your reason to be complete. Whenever you are identifying co-interior angles and you are saying the sum of these armpit angles gives you 180 degrees, please write co-interior angles, but don't forget to state the lines that are parallel. Whenever you are seeing the N or the Z effect relationship and you see these angles are alternate, please, whenever you state why the angles are equal, you must make sure that you write the reason and include the lines that are parallel. If you do that, then you will always be getting the marks that you need or that you deserve. So that's why, guys, angle E2 is equal to x. It's because alternate angles, the Z relationship with the lines that are parallel, makes it so that we say that angle E2 is also equal to this value of x as well. Okay. Right. Now, let's move on to the next question that they were asking. There's a follow-up question that they were asking. I'm just going to go and take it so that we can remind ourselves. The next question says, hence determine the value of x. Hence determine the value of x. What does this word hence mean? Hence means use something from what you have done in the previous question to answer the question that follows. That's what the word hence means. Use something in the previous question or in the previous answer. Use something in the previous question or answer to answer the question now that you are asked. They are saying, hence determine the value of x. Hence determine the value of x. So we now know that this is also x. Now all we want to do now is find the value of x. So I think we can all agree that we have a triangle here. Very good, Juice. Juice, you are thinking in the right direction. We have a triangle AEW here. This triangle AEW is an interesting triangle because what kind of triangle is AEW? You can see, guys, that this triangle, we were told that AE is equal to AW. So what kind of triangle is this? Yes, Liam, it is an isosceles triangle. Now, knowing that this triangle is isosceles, what can you tell me then about the angles of this isosceles triangle? There's something unique that we need to understand. The minute the sides are equal, there's something we know about the angles as well. Very good, Liam. Liam is on the money. Liam is like a cruiser right now. Like Liam is cruising. Liam has just said, and I want you to look at what Liam has said, because that is what we need to always keep in mind when we are referring to an isosceles triangle. So because the angles here are opposite the sides that are equal, we can then say the following, that angle W1 in triangle AEW, angle W1 is equal to angle E2, which is equal to X. But Miss Zim, we avoid base angles are equal. Now the reality is that yes, Miss Zim, angle E2 and angle W1 are the base angles of the isosceles triangle, right? I agree with you fully and completely. These are base angles of the isosceles triangle. So we say that these angles are equal, but the reason why we say they are equal, it's because according to the document, the acceptable reason document, these two angles are opposite sides that are both equal. So we say angle W1 is equal to angle E2, which is equal to X, and the reason we say that is because angles opposite equal sides. Angles opposite equal sides. This is our acceptable reason. Sometimes in the place of the equal, then the word they write equal as a symbol. So angle W1 and angle E2 are both equal to X. What's the reason? It's because these two angles are opposite sides that are equal. Please guys, this is an acceptable reason from the acceptable reason document. Okay. Are we together? In the comment section, let me know if you are understanding. So we don't use the reason that says base angles of an isosceles triangle. That reason is outdated. We don't use it. We don't say isosceles triangle because isosceles triangle as a reason won't help us. But because we know it's an isosceles triangle, the minute we see that the sides are equal, it means those sides are opposite the angles that should also be equal. So therefore we say those two angles, angle W1 and angle E2, which are both X, are equal to X, and the reason, angles opposite equal sides. Thank you very much. Now I can update my diagram and write X there as well. X is there, another X is there, and I have 70 degrees, which is in the diagram, which I was told angle EAW is 70. Now, can I now solve for X, guys? Alright, I think we can now go back to what Juice said initially. Juice did indicate in the beginning sum of triangle, but in order for us to do that, we are still in triangle AEW. What do we have in that triangle? We have 70 and we have two values of X. So now, because we've laid the foundation and my teacher can follow that, I have also indicated that the angle W1 is X. I can now go ahead and get the value, guys, of the angle X by doing what? By saying angle E2, which is that, plus angle W1, which is that, plus 70 degrees, which is that. Those are both equal to what? 180 degrees. What is the reason? Now, there's one of three reasons that you can write according to the acceptable reason document. Please take note. You can say sum of angles in triangle. That's one reason you can use. Or you could say angle sum in triangle. Or if you don't want that one, you could say int angles of triangle. Those are the three acceptable reasons that are provided in the acceptable reason document. Okay, Miss Zim, that document, if you go to Google and you go and search for any grade 10, 11, or 12 exam guideline. You go and type on Google grade 10 maths guideline, or you can say grade 11 maths guideline or grade 12 maths guideline. In that document, you will find the part that says acceptable reasons. It is basically a list of all the theorem statements in geometry, and on the right column, it has all of the short versions of the acceptable reasons that we ought to teach the learners when they are doing geometry. So this is a document that should be given to the learners so that they can be able to have it in their books, so that when they are in grade 8 and 9, they start getting used to writing those reasons in the way that they ought to be written. Okay, so angle E2, guys, we know angle E2 is x plus x plus 70 degrees is equal to 180. Now we can go ahead and solve for x. Guys, from here on, we are back in solving the equations. X plus x gives 2x. We take the 70, we transpose it. It joins the other numerical value. 180 minus 70. 2x is equal to 110 degrees. Okay, then from there, we divide both sides by 2. We get x is equal to 55 degrees. And there we have it. Okay. Alright. That was nice and smooth, wasn't it? Very enjoyable, right? Okay. How beautiful it is when we know our stuff, okay? Because it makes life so easy. It really is easy, isn't it? It truly is. It truly is. Okay. Right, guys, I'm sorry, I'm just going to take off the comment sections just a little bit so that I can now get you guys to focus on the next question. Okay. Sorry guys, just a little bit. I want us to look at the next question. We are told that ABCD is a parallelogram. So I'm hoping you guys can see the diagram very nicely. ABCD is a palm. Alright. So hopefully you guys are looking at this and you're like, okay, if it's a parallelogram, then it means the minute they say it is a parallelogram, it means all the properties that apply to a parallelogram are true. Those properties that apply to a parallelogram are true. Now what do they want from me? Calculate the size of who? Angle B. They want the size of what? Of angle B. For how many marks? For 4 marks. Now guys, the honest truth is that depending on who is doing the problem, there's so many ways to approach this question. Okay, so many ways to approach this question. So I'm just going to remove it a little bit here so that we can see the question, and I'm going to restore the comment section. All right, but hopefully we saw the question and we can now proceed. It's 4 marks, guys. 4 marks. Okay, this is 4 marks. What do they want? They want the size of angle B. All right, the size of angle B. Now, I know for a fact that some of you would approach this question in various ways. We are told that ABCD is a parallelogram. And remember, I said to you, all the properties of a parallelogram apply the minute they say it is a parallelogram. So, you can see Miss Zim already is firing away. Okay, you can see what Miss Zim is saying here. Miss Sim is saying angle B is equal to angle D. Alright, yes. So that information is going to be very important. And then Liam is also talking about co-interior angles. Okay. Now, if we want the actual size of angle B, we are going to ultimately have to do what? We are going to obviously have to get this angle B as a number. Alright, not just in terms of x. Currently, angle D is in terms of x, angle A is in terms of x. So we need to first solve for x. Okay, I like what Liam is saying in the comment section. We need to use co-interior angles to solve for x, then substitute and get D and B. Very good, Liam. Liam, very good. Brilliant thinking there. Got a brilliant mind there in Liam. Okay. So hopefully you can see that. What relationship exists between angle A and angle D? As Liam has said, these are co-interior angles. The armpit angles, the U shape, the armpits, the smelly stuff, right? The U. You see this U, this one. It's just like it's looking in a different direction one. It's now C, but it's still the armpits. Okay? And we remember we said the armpits, the sum of the armpit angles should give us 180 degrees. And remember, our reason is co-int angles, and we state parallel lines whenever we have to use that particular reason. So let's come here, right? We are already shown in the diagram that the lines are parallel. And remember, guys, when they say A, B, C, D is a parallelogram, even if the lines that are parallel were not there, we would be able to actually say that AB is parallel to CD. Okay? So that is one approach. Amon Queen or Amon Queen or whoever you are, my leader, you are saying, say, if we use sum of angles in a triangle, now, Amon, in order to use sum of angles in a triangle, what would you first have to do? You would first have to say that these two angles are equal, and you would have to give the reason why they are equal. So you would get 2x minus 20 degrees for angle B. Then you would also have to say these two angles are what? Are equal. And you would give the correct reason. And then after that, as you have said, you can use the sum of the angles of a quadrilateral, because you know that the sum of the angles of a quadrilateral are 360 degrees. Okay. Brody, okay. So yes, that is another way Amon, that you can approach this question. You see, so that's what's beautiful about geometry, is that there are many ways to approach the problem that is before us. So just give me a sec. Okay, I'm going to actually look. Sorry, I just need to get. Maybe it's the days when maths didn't have shapes. Unfortunately, you can't run away from it. You can't run away from it. Okay, so let's look at all of these approaches. Okay, let's first look at how Liam and Miss Zim saw things that we need to just look at. Thank you, Tseho. Thank you so much for the rose. I really appreciate it. Okay, let's look at these ways that you guys have come up with here, and then let's see. Thank you so much, guys, for the gifts. They mean a lot. Okay, so let's first look at what Liam and Miss Zim. Liam and Miss Zim. So Miss Zim first said angle D. Remember, we are told that ABCD is a parallelogram. If it is, guys, then we know that the properties of the parallelogram will apply here. All right. So one person can then say angle D and angle A, first and foremost, are co-interior angles, U-shape. Why are we saying the U-shape? Because these are the armpit angles. The armpits, they stink, so we add angles together. So what we would say is, we would say angle A plus angle D is equal to 180 degrees. What's the reason? Co-int angles. Then what do? We state the two parallel lines. My arms are AB and DC. Those two lines, these would be my arms, those are my armpits. Where it stinks, we add them together, we get 180. We add roll on and it will smell better. Co-interior angles AB is parallel to DC. Then we can say x plus 50 degrees plus 2x minus 20 degrees is equal to 180 degrees. All right, remember this is a binomial, but obviously since it is an expression representing an angle, we know it becomes in brackets a monomial. We can then remove the brackets. X plus 50, 2x minus 20 is equal to 180. Then you can add the like terms, x and 2x together. We're going to say x, the 2x is positive, so we bring it together as x plus 2x. We take the negative 20, we transpose it, it becomes positive 20 because it was negative 20. We take the plus 50, we transpose it, it was positive, the other side it becomes negative. Then we say x plus 2x gives us 3x, and then 180 plus 20 is 200. 200 minus 50 gives us 150. And then we divide both sides by who? By 3. And then we get a beautiful answer of x is equal to 50 degrees. This makes life easy when we actually get our value of x. When we know what the value of x is, guys, then after that, all is well. Okay, now you remember what Miss Zim said. Miss Zim said this angle for a parallelogram. We know our properties for a parallelogram. We know that for a parallelogram, the opposite angles are what? They are equal. So currently our angle D, if we substitute the 50 degrees in the place of x, remember this is 2x, in the place of x we substitute 50 in brackets, and then we subtract the 20. And then, like Mrs. Zim in the comment section is saying so beautifully to us, let me just approve your comment, Miss Zim, so that your comment can shine very bright for us to all see. Okay, I don't know, I'm having problems with unfiltering it. But Miss Zim already in the comment section, I can see the comment, but unfortunately it's just my, yeah. So 2x minus 20 is angle D. In the place of x, I substitute the value of x that I got, which is 50. So it's 2 times the 50 minus what? The 20. 2 times 50 is what? 100. Minus the 20 gives us 80 degrees. That is angle D. But we know that angle D is equal to, the symbol of, for short, and then parallelogram can be written as, in short, parallel lines with M. This actually means parallelogram, in short. So that is the value of angle B. Angle B is actually equal to what? To 80 degrees. That is the size of angle B. This is one way that you can actually do this question for 4 marks. Okay? One way. Now, this is not the only way. Okay? Depending on who's doing the maths problem, someone else indicated earlier on, can't we use sum of angles in a quadrilateral? And I am saying definitely yes we can. Okay, definitely yes we can. I'm sure you guys can see how we can use sum of angles in a quadrilateral to basically get x, and then ultimately to be able to get the angle B, you know. So for instance, someone else who's looking at this question could look at it and be like, okay, sir, from what I can see, good morning, Smart Dad. From what I can see, angle B and angle D. Okay, you are absolutely correct, Leon. Okay, but at the end of the day, it leads to the answer. So for instance, someone else who's looking at the question for the first time could be like, okay, sir, I see this is a parallelogram. Knowing the properties of a parallelogram, a person will then say, this angle D and this angle B, they are equal. So someone will say angle D is equal to angle B from the get-go, which is equal to 2x minus 20 degrees. So we get angle B in terms of x. What's the reason? Op angles of parallelogram. Then we obviously update the diagram. Then someone else says angle A is equal to angle C which is equal to x plus 50 degrees. And I ask, what's the reason? Op angles of parallelogram. And after doing that, then obviously we update what we have. We add all 4 angles together. When we do, it's a matter of just saying x plus 50 degrees plus x plus 50 degrees plus 2x minus 20 degrees plus 2x minus 20 degrees is equal to 360 degrees. Why? Int angles of quad. Okay, interior angles of quadrilateral. Okay, yeah, maybe someone else can say sum of angles in quad. Okay, so which is fine. Okay, there's no specific, but I mean anything that's a variation that could sort of like suggest that you understand that the inside angles of a quadrilateral should add up to 360 degrees. Now all we do now is we are going to solve this question. Take the x's together. This x is positive, that x is positive, that 2x is also positive, that 2x is also positive. And let's take all the numbers to the other side. 360 minus this 20, positive 20 on the other side. This 20, negative 20, positive 20 on the other side. This positive 50, negative 50 on the other side. And this positive 50, negative 50 on the other side. Then we add everything together here. So this is what? 6x. And then here, okay, we add these together. Okay, Smart Study is the man to go to, guys. If you don't know, let me just do that. I think let me give this guy his moment. Okay, Smart Study in the comment section, guys. There's a person there. Smart Study. Smart Study has a TikTok page where he uploads, guys. He uploads question papers for days, recently written question papers, previous question papers, grade 8, grade 9, grade 10, grade 11, grade 12, everything, resources for days, revision packs for days. If you want resources, guys, you are Term 1, Term 2, Term 3, Term 4, everything, grade 8 to 12, every subject. Go onto that page, follow him. You will get resources for days. Very, very resourceful. If you're preparing for those tests, then he has got the resources. If you want previous test papers written in Term 3 in previous years, he's got the resources. Yeah, for days. Okay, 360. Let's add this. So when we add this, guys, what do we get here? 360 plus 20 plus 20. That's 400 minus another 100. 400 minus 100 gives us, and then we divide both sides by the coefficient. You get x that is 50 degrees. Now remember, you wanted the size of angle what? Of angle B. You have angle B in terms of x. It's 2x minus 20, because remember, that's how you started. So now you can say 2 into, you got x is 50, so you substitute in brackets. Guys, whenever you substitute something, you substitute it and you use brackets. In the place of the x, the 2 and the x are multiplied together, it combines them. So brackets mean multiply. 2 times this 50 degrees minus the 20 will give you 100 minus the 20, which means angle B, the size is 80 degrees. So this is another way to get angle B for the 4 marks that you needed. You see, so everything can be done. It definitely can be done. So my fellow grade 8s and 9s, there's there should be no issue really. All right, if you know your properties for all quadrilaterals, for triangles and everything, then you should be able to get to a place where you can solve a question. No problems asked. Okay? No problems had. Okay? Yeah. Alright? So 2 ways. These are 2 different approaches, but they all lead to the same what? To the same answer or conclusion. Alright? Okay. Hopefully that's clear. That's clear. Very clear. No problems at all. Let's see if we can't find another question here. Hey, let's come here. Ooh, guys, look at this one. This is a November 2019, taken from an December 2019 question paper, written in the Eastern Cape, EC, 2019. Okay, but I mean, these are where people go and harvest questions. They, your teachers, when they are setting papers, they usually go to past papers and they want to check what kinds of questions were being asked in exams in previous years, and then they select certain questions and then they put them in the tests that you guys write. All right, so it's very good when you are able to, after learning all of the work, after covering all of the work, when you've covered everything, then you can actually go ahead and actually sort out if you understand. Look at 6.4, guys. Okay, it's a question, 6.4.1. It's a question around congruency. Very basic congruency, very easy congruency. All right, and then 6.5 is a question regarding similarity. Also very easy similarity, very easy. You guys need to first understand the concept behind these 2 topics. Once you understand the concept and you understand what these things mean, then you can be able to apply them in the appropriate way. They are not difficult, guys. They are very easy. So let's look at this one, 6.4. Prove that triangle ABD. It says in the figure below, firstly, AB is equal to AC. So we are given that AB is equal to AC. We are also given that BD is equal to what? CD. Then they are saying in 6.4.1, prove that triangle ABD is congruent to triangle what? ACD. Okay, remember, what does congruency mean? Congruency means, in simple terms, the same shape. Prove that the triangles are the same. They look identical. When we talk about congruence, we are talking about identical. Two identical things are what we call congruent things. So I like what is being said in the comment. They have the same shape and the same size, same angle, same length. So if you look at the length of those 2 triangles, the lengths, the corresponding lengths or sides should be the same. If you look at the angles, the corresponding angles should be the same. Okay, yeah. So it's the same thing, guys. Same. No. We don't mean it's equilateral, because remember, when you say equilateral, an equilateral triangle will have angles that are 60, 60, 60. All right, but you are saying that they have the same equal angles and the same equal sides. That's what congruency means. Same equal angles and same equal sides. Same equal angles and same equal sides. That's congruency. Same equal angles and same equal sides. Congruency has 4 cases for triangles. How many cases? 4 cases. I want us to look at the cases, guys. There are 4 cases of congruence. Case number 1, side, side, side. In other words, the sides for the 2 triangles are the same. 2, there's side, angle, side. Now this angle should always be in the middle on purpose, right? 3, there's AAS, or sometimes they say it's SAA, or I guess sometimes they say it's ASA. All right. Take note, guys, that this one has variations It's two angles, two angles, two angles, one side, one side, one side. It's one thing. But this one does not have variations. This one has, it must be a side. In the middle, there must be an angle sandwiched between the sides. That's the only way in which you are able to prove this one. And then, of course, SSS, because it's side, side, side. Number 4, RHS. RHS. These are the only 4 cases for what? For congruency. These are the only ones. There's no other. Okay? So we said same angles, same equal angles, and same equal sides, and same equal angles and same equal sides. Okay, then guys, similarity, on the other hand, can be proven in 2 ways. But what is similarity? Guys, similarity is when things are equiangular. In other words, equal angles and proportional sides. Not equal sides, but what? Proportional sides. So equal angles and proportional sides. Okay, that's similarity. Okay, equal angles and proportional sides. That's what we mean by similarity. And so the first case for similarity is AAA. In other words, angle, angle, angle. If that way doesn't work, we can always prove that corresponding sides are in the same proportion or ratio. And ratio is just another way of saying fraction. Ratio and fraction are the same thing. Okay, one of 2 ways of proving similarity. Okay, so this is so important. Okay, I love telling learners that similarity means equiangular. In other words, equal angles. Equiangular. And in the same way, equiangular means same proportion. Okay, proportional sides. And proportional sides also means similarity. Okay, similarity means equiangular, equiangular means similarity. Similarity means proportional side, proportional sides means similarity. Proportional sides means equiangular, and equiangular means proportional sides. These have an interplay. So if you say the triangles are similar, you must know that you are saying the angles are equal, you are also saying that the sides are in the same proportion. If you say that for 2 triangles, the triangles are equiangular, you are saying that the sides are in proportion. And if you are saying that the sides are in proportion, you are saying the triangles are similar, and vice versa. Alright, so basically there's a relationship that exists between similar triangles, equal angles, proportional sides. We need to understand this very well so that when we are given questions, it's not difficult to answer. So this is very important. Okay? So I hope you guys are following. So let's go back to the question that we were asked. 6.4.1 says prove what? Prove that triangle APD is congruent to triangle what? Yeah, so hopefully you can see, guys. Right. So I'm going to redraw this diagram. It's not going to be perfect, okay, because I'm using my other hand to hold the phone and then the other one to actually write. Okay. Prove that what? Triangle ABD is what? Congruent to triangle ACD. Okay, so I've just tried to reproduce that diagram, but you've seen it, guys. Hopefully you've seen it. Now already, what can we see here? We are told that AB is equal already, guys. We are told that AB is equal to AC. So what we are going to say, because the question says prove, it means we are required to prove that triangle ABD is congruent. Remember, the symbol of 3 lines that are horizontal means congruent. And congruency, if we are to prove it, we can prove it under one of 4 cases. It's either we're going to prove this one, or this one, or this one, or that one. So when we go to the diagram, it's very clear that we can see that AB is equal to AC. AB is equal to AC. What is the reason? It is given. Thank you, Lifa. That basically gives us our first pair of what? Of equal sides. Okay, so I usually like writing the letters so that I can see which case comes out at the end. Are you with me? So I said AB is equal to AC. That is given to me. It was stated in the statement that AB is equal to AC. And in the diagram, you see this line and that line. Those 2 lines indicate equality of sides. So that's why I'm saying AB is equal to AC. Next statement. 2, 2. BD is equal to DC. Why? Given. This is another pair of sides that are equal. It's given to me, guys, that that's the case. All right. So this side we say is a corresponding side because this is the same side of 2 different triangles. In this triangle, this side is the same side for this triangle. That's why we call them corresponding sides. So AB is equal to AC. It's given that they are equal. BD is equal to DC. These 2 symbols indicate that the sign symbol that is the same indicates equal sides. That is my second pair. Then lastly, as Mrs. Zim is saying, AD is a shared side for both triangles and it is common, and therefore it is implied that it is equal for both triangles. So we say AD is equal to AD. AD for this triangle ADB and AD for this triangle ADC. AD is equal to AD. Why? We say common side. Common side is our reason. That is our third pair of equal sides. So we have our third S. Now we can conclude. Go back to the statement. The order is triangle. Let's go triangle ABD. Then we write the 3 horizontal lines for congruency. And then we say triangle ACD. What is the case? Because in the concluding statement, you must write the case that you have just unleashed to validate that triangle ABD is congruent to triangle ACD. You see, that's why I wrote my S's here. 1, 2, 3. Now I can write in brackets S, S, S. And how many marks, guys? 4 marks. 1 mark for statement and reason, 1 mark. Another mark for statement with reason. Another mark for statement with reason. And then lastly, the concluding statement, which is the 2 triangles being congruent with the reason. 1, 2, 3, 4 marks. If you don't have the reasons, guys, you are basically saying, I don't want this mark. No reason, I don't want this mark. No reason, I don't want this mark. No reason, I don't want this mark. You are forfeiting marks when you don't write your reasons. Okay, so this SOR is just to say, I am giving you a mark for the correct statement. AB is equal to AC is the statement. And R means the correct reason. Together gives you the 1 mark. So the first pair, the statement with the reason, gives me 1 mark. The second pair, the statement with the reason, gives you the 2nd mark. The third pair, the statement with the reason, gives you the mark. And then lastly, the concluding statement, triangle ABD being congruent to triangle ACD. The statement, the concluding statement with the reason gives you the 4th mark. So that's what SOR means, statement with the reason. Okay, thank you so much, Her Life. I really appreciate the roses. It is very much appreciated. Guys, can I also show you something? If you look at the order of what they said you must prove, please take note of what I'm going to now show you. AB, you see this AB? Look, AB. Look at the other triangle, the first 2. AC, look, AC. Let's look at the last 2. BD, BD. Look at the last 2. CD, there it is. DC, CD is the same thing. Then lastly, look at the first and the last. That's A and D. Look at the first and the last. That's A and D. AD is equal to AD, common side. So when you conclude and you say triangle ABD is congruent to triangle ACD, the order of your letters is very important, which is why when I'm writing my concluding statement, I go back to what they wanted me to prove. I take this guy here and I write him at the end, and I write my case. Case closed. Case closed. The triangles are what? Are congruent. Let's go on to the next question. Look at 6.4.2. 6.4.2. Once again, this word hence. Hence prove that DA bisects BAC. For what? For 1 mark. I want to unpack what this means. Yes, Mapangwa, I am. I'm a teacher, right? Hence prove that DA bisects. What does this word bisect mean? The word bisect. I want someone in the comment section to help me out. And then look at this. This is a line. In DA is a line. Let's agree that this is a line. DA is a line. What is it doing? Bisecting. Okay, Siatelegi, I like what you are saying there in the comment section. Let me just allow that. Yes, cut in half, split in half. I'm going to write these things that these people are writing. Siatelegi is saying cut in half. Someone else is saying split in half. Yes, I like it. I like it. Her Life, thank you so much. So bisect means to cut in half. If, let's say, for instance, I have an orange and I cut it in half, it means one side is going to be, the one part of the orange will be equal to the other part of the orange, and then I'll be able to share it equally. Okay, so I'm just going to write that one as well. Share it equally. Yeah, once we cut it in half, we are able to share it equally. Thank you so much. But what are we cutting? This is very important. What are we cutting here? The line DA is cutting what into half? Equally. It's cutting who? Angle. It's cutting an angle, which is what? BAC. Let's go and locate what BAC is. BAC. Now, BAC is this entire angle. BAC. Now, they are saying we must prove that AD cuts BAC. Right? So, in other words, they want us to prove that angle A1 is equal to angle what? A2. They want us to show that. Iconic, thank you so much. Iconic dimples. Bisection, divide equally into two equal parts or angle. So we are having a situation where a line is cutting an angle. If the line cuts an angle into half, what are we saying? We are saying we are sharing angle A equally. So A1 should be equal to what? To E2. We are being asked to prove that. So how are we going to do that? We are going to hence. What does hence mean? Hence means use something from what you have done above to prove that angle A1 is equal to angle A2. Now look at this, guys. What did we just prove in the previous question? We proved that triangle ABD is congruent to triangle ACD. Now, can you agree with me about something? Remember when we defined congruency, didn't we say that when shapes are congruent, it means that they have the same equal angles and the same equal sides, the same equal corresponding angles, the same equal corresponding sides. That's what congruency means, because congruency speaks to things being identical, the same. So then, can we agree, guys? Can we all agree? Can we agree that angle A, this angle A for this triangle, if the triangles are congruent, as we have already proven, can we then all agree that this angle is equal to that one? And that angle is equal to that one? And that angle is equal to that one? Can we agree on that, guys? We've proven that the two triangles are congruent already, and we have stated our case for congruence. Can't we then conclude that the angle A of triangle ABD is equal to the angle A of triangle ACD? But what is that? Let's go and check. Who is the angle A of triangle ABD? Isn't the angle A of triangle ABD actually angle A1? Isn't that angle A1? Isn't that the angle A that we are speaking about here? Since these triangles are congruent, can't we then conclude that angle A1 in actual fact is equal? If the triangles are congruent, what about this angle A? This angle A for triangle ACD, what angle is that? Let's go. ACD. Isn't the angle A for triangle ADC, isn't that angle A2? Isn't that angle A2, guys? It is. So we can say angle A1 is equal to angle A2. Why are we saying that? It's because, guys, triangle ABD is congruent to triangle ACD for the case of congruency that we had spoken, which is SSS. Does that make sense, guys? So that's why we say angle A1 is equal to angle A2. Therefore, DA bisects BAC. BAC. Hey life, you're asking why is it SSS? We had just done this question. SSS, guys, means side my first pair of sides, side, my second pair of sides, sides, my third pair of sides, which therefore led us to say triangle ABD is congruent to triangle ACD. Okay. Now, because of having proven that triangle ABD is congruent to triangle ACD, this is how we went about it. We said AB is equal to AC. We said it's given. Then we said BD is equal to DC. We said it's given. And then we said AD is equal to AD, the common side. Then we concluded triangle ABD is congruent to triangle ACD. Case SSS. Now that that is true, we are asked in the next question, hence, this word hence means use something that you've done in the previous question. Use something you have done. Use something in the previous. Use something, hence. Okay. Hence prove that DA, what is DA? DA is the line, this one. That common side for the two triangles is DA. They are saying hence prove that DA bisects. What does the word bisect? We've just unpacked that bisect means cut in half. Two, it means to split in half. It means to share something equal. We are sharing equally who? BAC. We are saying we want to prove that DA actually cuts angle BAC. What is BAC? BAC. This entire angle can be cut in half. In other words, A1 and A2 are equal. We want to prove that. So because we had already proven in the previous question that triangle ABD is congruent to triangle ACD, we have said that, what does congruency mean? It means we have the same equal angles. The minute, guys, we say that the triangles are congruent, we are done. We are basically saying that those two triangles are the same equal, have the same equal angles, and they also have the same equal sides. All cases of congruency apply for that triangle the minute you are able to prove one case of congruence. In fact, at least the first three. All right, because right angled hypotenuse side, obviously, if there's no right angle, so there's no right angle. But we understand that there's same equal angles and same equal sides. Therefore, this angle A is equal to that angle A. But the question is, this angle A for triangle ABD is which angle? This is triangle ABD. What is the angle A we're talking about? It's angle A1, this one. Okay? And then for triangle ACD, in that first position, we have A as well. So that A and that A are equal because the order is correct for congruent triangles. This angle A should be equal to that angle A because of congruent triangles. Okay? So I say now, which one is angle A for triangle ACD? This is triangle ACD. That angle A we're talking about is angle A2. So this is A1, guys. This is A2. All right. Guys, this also is true. This angle B and this angle C, this angle B and that angle C are equal. And lastly, this D, this angle D, which is angle D1, and that angle D, which is angle D2, are also equal. This is very important, guys, when triangles are congruent. So the question here is saying we must prove that DA bisects BAC. In other words, the angles, angle A1 and angle A2, are equal. If they are equal, then it means DA bisects BAC. So now I can say, therefore, based on the congruence of the two triangles, angle A1 there is equal to angle A2 there. Why? Because of congruent triangles. Okay. Now, I just wrote all of this just to make the point. But guys, you could just say congruent triangles as your reason. Just write congruent triangles. The person who's marking your work will understand you had just proven that the two triangles are congruent for this case. Now you are saying angle A1 is equal to angle A2. Why? Congruent triangles. Then you can say DA truly does do what? Bisect what? BAC. Because you can see angle A1 is equal to angle A2, so DA truly does bisect BAC. BAC. But I'm sure you guys can also see that DA does not only bisect angle BAC, DA also bisects this angle D, because D1 is also equal to what? To D2. According to the what? Angle D1 is also equal to angle D2. That's just something else to think about. But obviously for this question that we were asked, we were able to answer that question because triangles are congruent. Okay. Yeah, I think guys, today has been a good day. All right, good one. Just gonna do this last question and then we'll call it a day for today. All right, just so that we are in the same page. Now we're looking at another question here. I'm just gonna remove the comment section so that you guys can see something here. Yes.
Because when I sleep, my eyes, like when I try to open my eye, it's not open.
All right, so here we are now with the next question. In triangle PQR, all right, in triangle PQR and a triangle STR, they are saying PQ is parallel to ST. I'm sure you guys can see that. They're saying PR is equal to 10 centimeters, ST is equal to 3 centimeters, and SR is equal to 6 centimeters. Then they are asking, show that triangle PQR is similar to triangle STR. So I'm just going to try and redraw this diagram. Okay, so that we can actually then look at this question. What do you mean you can't hear anything? Who can't hear anything? I've unmuted. What do you mean we can? I can hear. All right, I can hear myself as well. So I'm gonna do this last question, guys, and then we'll call it a day for today. So triangle okay, so we're gonna show that triangle PQR is similar to triangle STR. Okay, all right, so I hope you can see the question a little bit better there. I'm just gonna remove it slightly. I think not even remove it slightly, let's just remove it entirely. Okay, here we are. So we need to show that triangle PQR is similar to triangle STR. Now, remember earlier on, we spoke about the concept of similarity. And when I explained similarity, I said to you guys that when you prove similarity, you prove it using one of two ways. Okay, you can either prove similarity use equal angles, okay, which is AAA, or you can prove similarity using sides in proportion. Okay, yeah, you forgot the S. Oh yeah, thank you. Thank you about that. Nobody knows. Okay, so remember, sides in proportion needs you to have all three sides of the respective triangles. In order to use sides in proportion, you need to have all three sides of the respective sides of the triangle. Now, what you can look at here is that if you look at PQR, we have insufficient information. This is 10 centimeters. We don't have QR. We don't have PQ. So we don't have sides that are sufficient in order to use sides in proportion to prove the similarity of the triangles. If you look at triangle STR as well, though we have ST and we have SR, we don't have RT. So we are going to not even consider using sides in proportion to prove the similarity of the triangles. So that means we need to then look at another option, which is we need to look at proving equal angles. Okay, so if we're going to prove equal angles, let's then look at the diagram and then check what is there for us to be able to use. So if you look at the diagram, guys, we have two lines here that are intersecting, and these two angles, surely we know that there's a relationship that exists between these two angles, right? Yeah, so that means angle R1 is equal to angle R2. What is the reason? Angle R1 is equal to angle R2. What is the reason for saying angle R1 is equal to angle R2? I've slightly modified the diagram, guys, so that I can be able to utilize the diagram for the purpose of actually answering questions. Okay. Maybe what we can do actually is just revert back to what was in the diagram so that maybe we can learn something from it. No problem. Let me just do this. The diagram had 1 here, it had 2 there, it had nothing there. So let's let it be like that then. Okay. So what we can then say is angle R1, because we are given it as angle R1, is equal to what? It's equal to angle SRT. Remember, if we don't have a number to indicate an angle, we can always use the direction of what we have to say. You can say this is angle SRT with a cap on top of R, or we can say this is angle TRS. Okay. What's the reason for saying these two angles are equal? Vertically opposite angles equal. That's why angle R1 is equal to angle SRT. Vert op angles equal. That's from the acceptable reason document. Then we can see that these lines are parallel, guys. So that means we have our Z shape here. This angle we can say is equal to that angle because we can see, Mr. Z, the two angles are equal. So in other words, we can say angle QPR is equal to angle TSR. The reason, alt angles, we state the lines that are parallel. PQ is parallel to TS. PQ is parallel to TS. don't forget the parallel lines, because if you do, then you are not having a complete reason. This is my first pair of angles. This is my second pair of angles. Now I need a third pair of angles so that I can then fully complete this similarity of triangles. My first two angles are taken care of. I need one more. I'm sure you can see that this angle is another Mr. Z. This angle and that angle. This angle and that angle. That's another Z angle. There we have Z effect again. So we can say angle PQR is equal to angle STR. What's the reason? Alt angles. Lines that are parallel. P2 is parallel to TS. That's my third pair of angles. Angle, angle, angle. Now I can now conclude that triangle. Let's come here. PQR is similar to triangle STR. Using angle, angle, angle. First pair, 1 mark. Second pair with statement and reason, 1 mark. Statement and reason, 1 mark. Concluding statement with the case of similarity. Angle, angle, angle. Okay. Any questions? Now something you need to note here is that the angle P, this angle P is in actual fact equal to that angle S for that triangle. This here supports that. This angle Q is equal to this angle T for the triangle. There, that supports that. This angle R is equal to that angle R. That statement supports that. And all I needed were what? Were reasons to support the equality of those angles, so that this could be true for these two triangles. Okay. Who wouldn't want to award you 4 marks if you prove similarity of these two triangles using angle, angle, angle? Okay. Remember, guys, sometimes you can use this as well. Instead of saying AAA, you can say angle, angle, angle. This is the same thing basically. Okay, one and the same thing. Right. So grade 8s and grade 8s and 9s. Hopefully, we are getting this, and we are slowly but surely coming along, and we are seeing. Oh, okay, okay, all right, okay, 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 right. Okay, the next question says, and I want to calculate the length of PQ. Calculate what? The length. The length of who? Of PQ. For how many marks? For 3 marks. We've already gotten the 4 marks for similarity of triangles. Now we need to calculate the length of PQ. Okay. PQ, we can see where PQ is, right? So we want the length of PQ, to calculate the length of PQ. So the $1 million question is, how do we calculate the length of PQ? Once we prove similarity of triangles, let's remember something that we said earlier on, that if triangles are similar, then what do we know about the sides? The sides are in the same what? Proportion. And if the sides are in the same proportion, we say that the angles are also equiangular, right? You remember that little diagram I actually wrote up here, and I said similarity means proportion, proportion means similarity, similarity means equiangular, equiangular means proportion, proportion means equiangular. So because the triangles are similar, this is what I want you guys to note, guys. Take note of this. Because these triangles are similar, I can write my sides in proportion. Look at this. You see this PQ and this ST. What I'm going to say is I'm going to create a ratio using my first two sides. PQ over ST. Do you see that? first two fraction, ratio, proportion, equal, last two, QR over TR, first and last, PR over TR. Why do we say that? Because of similar triangles. Very important what I've just done here. Because triangles are similar, you can now write the sides in the same proportion. Are you with me, guys? Hey, I hope you are with me here. Okay, let's check one more time. PQ over ST. Okay, are we good? All right, I think I butchered the last one. I'll check it out just now. Thank you so much. I like people who are active in the comment section. PQ over ST. PQ over ST is equal to QR over TR. That's fine. Then the last one. PR first and the last. SR first and the last. I wrote TR. What nonsense is this? SR. Thank you so much. Who is this? Zozetu. Is it cool? Hi, you guys with your names on yeah. But thank you so much. I really appreciate you actually helping me out there. Okay, so I repeat once again, because we've just proven that triangles are similar, that means that the sides are in the same proportion. Remember, similarity means proportional sides. All right, so since we've proven that the triangles are similar using the angles, okay, cool, thank you. Since we've proved similarity of triangles using the angles, remember, we've just used equiangular to prove similarity. So similarity means the sides are in proportion. Proportional means equiangular. Equiangular means similarity. It's like guys, it's a reversible thing, man, you know? Yeah. Similarity means proportionality. Proportionality means equiangular. Equiangular means proportionality, and proportionality means similarity. Similarity means equiangular. Equiangular means similarity. It's like, it plays like that. So because the triangles are similar, I can now write my sides in the same proportion. How? You see PQ, my first two letters for each triangle can be written as a ratio. PQ over ST, here it is, PQ over ST is equal to what? Last two letters, QR over TR, there it is, QR over TR. Then my first and my last, PR over SR, PR over R. These ratios are the same. The sides are in the same proportion. Why? Because the triangles that we have just proven are truly similar. So we write the same ratio and we say they are equal. Why? Because triangles are similar. Okay. Now, what do I want? The length of PQ. Now I am interested to take the two. I'm going to choose two ratios to solve for PQ. Obviously, my priority ratio will be the one that has PQ. So for instance, PQ over ST. I'm going to take PQ over ST, no doubt. So PQ over ST is coming along, no problem. He's coming along, oh, PQ over ST. He is my friend. PQ over ST is coming along because PQ is something I want. ST, I need to go check the diagram. Does ST have a length? Yes, it's 3. So that means PQ over 3. It's coming along definitely. Now let's check the next fraction. Can I take him along? Does he have enough information? Does he have information for me to be able to take him along? Guys, if a friend does not have money and you want to go to a restaurant and you don't have enough money to take both of you out, but you can share the expenses, if that friend does not have money, you're not going to take him along. But if he has money, you are going to take him along. So we are asking, which two fractions can we take? The ones that have the one that what we want and they have money. So PQ over 3, there's something there. ST has something to give. What about QR? Let's go check. QR, is there any information that we have in the diagram? QR is empty. No money. He's broke. We are not taking him along. So sorry. You are not coming with. Let's check TR. TR, is broke. We are not taking him along. Goodbye. When you are gone. Sorry. PR. Where is PR? Let's check. Does PR have information? Yes. 10. So that means we are going to say equal to PR over. Let's check if SR has information. SR has 6. Yes. We can take him along. So the two fractions that I'm going to equate together are PQ over ST is equal to PR over SR. Now let's fill in the information. PR, what is PR? From the diagram, PR is 10. SR from the diagram, what is SR from the diagram? SR is 6. And remember guys, what was the reason for doing this? Similar triangles. But what's nice is that the reason was there in the beginning, so that's enough. If I have the reason in the beginning, it's a matter of after statement, reason, I choose the two ratios that have money, the two ratios that have info, along with what I want because it's missing. Then now we can play the gray game of cross multiplying. I am going to cross multiply, or in other words, I am going to use what? I'm going to use my concept of LCD to find the value of PQ. Emmanuel wants to see the triangle. There it is, Emmanuel. PQR and then STR. There is the triangle. Hopefully you've seen it enough, Emmanuel. Let's cross multiply. So that's what happens. I cross multiply 10 times 3, leaving PQ alone. 10 times 3 is 30. 30 divided by 6 is 5. So PQ is equal to 5. And that concludes my calculation. And that is the length of PQ. Okay. So please guys, similarity is not that difficult or that painful. Okay. Yeah. So I think now that's it, at least for today, that's it. The length of PQ, this would be 3 marks. It's 3 marks because of the statement there, substitution with the reason. Yeah. Yeah. Okay. So if you want to check this thing out again, you can go to the channel itself, and then you can rewatch it, because some of you joined now and I will not be explaining again. I can't explain the same thing over and over again. Yeah. Yes, definitely help there. Okay, so here, all right, what we do is we cross multiply, guys. We cross multiply, or you could use the LCD. You know most that usually when you have equations, you ask yourself, what is the LCD between 3 and 6? That LCD between 3 and 6 is 18. No, not 18 actually. It's 6. The lowest common denominator between 3 and 6 is 6. So that means you can multiply this side by 6, and then you can multiply this side by 6 as well. And then what happens, this 3 goes into 6 2 times, you get 2 here. So it's 2 times PQ, And then the 6 and the 6, they cancel out. You are left with 10 that side. And then you can divide both sides by 2 and you get the length of PQ, which is 5. So this is one way of looking at how to do this question. Or like I said, you can cross multiply. Okay. Yeah.